Just a recap on the nucleophilic addition elimination reaction. We've seen this before in the carboxylic acids pack. See if you can complete this mechanism. Well done if you got to this stage. So your intermediate should have the two charges on, so the oxygen negatively charged, the nitrogen positively charged, and then, as we saw before, we've got three arrows, so reforming the double bond, kicking the chlorine out, and the nitrogen gets its electrons back by losing the proton. You will see this done by perhaps bringing another ammonia along to remove that hydrogen, although that's not necessary for the exam. In losing the proton, the NH3 plus becomes an NH2. Here's our organic product. This looks like it's going to be an amine again, having the NH2, but because the NH2 is directly attached to the carbonyl group, this gives us a new kind of compound, and this is an amide. Of course, if ammonia can act as a nucleophile in this reaction, so can an amine. We're using a primary amine here. Have a go at this mechanism. Well, I'm hoping that you got to this stage, so from the intermediate, it's those usual arrows again. Just make sure that we pick one of the hydrogens to lose and not the methyl group. What's this going to give us? Well, we've kicked the chloride out, and we've got the amine group directly attached to the carbonyl group. So again, this is an amide, not quite as simple as the previous example, as we've got an alkyl group substituted onto the nitrogen, so these would be regarded as an N substituted amide. To name this particular example, very simple example, then the first thing, let's look at the amide itself. So there are two carbons in the amide, so this is ethanamide, and if there was just a hydrogen attached to the nitrogen rather than the methyl group, then that would be the name, ethanamide. But we need to talk about the fact that we do have a methyl group, and we also need to say that the methyl group is attached to the nitrogen and not the other side. So this is N-methyl ethanamide.